team. My name is Mahesh. In this video, we are totally looking into Kubernetes part itself. Inside of Kubernetes, we are focusing on multiple topics that we are looking in this particular video. In this video, we are looking into architecture of the Kubernetes, how the Kubernetes architecture works, what are the components inside a worker node and the master node architecture that we are looking. What are the benefits and the advantages with the Kubernetes that we are looking in this video. So before we moving forward, we are using this PPT that are created by Vikram. You can refer this PPT to understand the Kubernetes in depth itself. So what is a container? Kubernetes platform is basically used for the container orchestration platform. What is meant by container orchestration platform? Container orchestration platform will automate the deployment process, the management, the scaling, auto healing, networking. All those topics are managed under container orchestration itself. The container inside a container orchestration itself. So what is provided by what is exactly container orchestration do, such as the Kubernetes we are looking. It configure and scheduling the Kubernetes configure and scheduling containers, provision and deployment of containers. It increases the redundancy and availability of the container because it has some enterprise level features and all those things we looking forward. So it supports scaling. It will auto scale upon the request according to the request that came into Kubernetes API. With that, it will automatically scale up and scale down the pods. We can say, what is a pod? We look into that. So it is provide a proper resource allocation that are needed to host multiple pods inside a Kubernetes cluster. It will support a load balancing. It will automatically load balance between the multiple nodes and multiple container or pods. We can say it will automatically do those load balancing activity. And health monitoring, as I said, it will support the health monitoring because if one of your container goes down, suppose one of the container goes down, it will automatically sense and it will reported to the Kubernetes master itself, and the Kubernetes master will create another container for it. So this is how the things work. So what is Kubernetes? Kubernetes is also known as a KITS. It is an open source container management tool, as we said. It provides a container runtime, container orchestration, and the container centric infrastructure orchestration. It supports auto healing, service discovery, load balancing, and the container descaling and upscaling and descaling. Previously, it is created by the Google, and it is a sub part of the Borg, Google Borg, we can say. But now it is donated to the CNCF community. So they are managing and all those things are done by the CNCF now. So it is written in the Golang language, and that's overall things you need to know right now. So the Kubernetes cluster is a set of physical or virtual machines or other infrastructure resources that are need to run your containerized application. So what does it mean? Each virtual machine in the Kubernetes cluster called as a nodes. Inside that node, you put your application inside a node. Node is basically a container that are wrapped inside a particular shell, which is called as a pod. In the Kubernetes stuff, that shell is called as a pod. So a Kubernetes cluster is a set of physical or virtual machine and other infrastructure resources that are need to run by a containerized application. Kubernetes provides a set of worker node components, such as the container runtime, the kube layer, such as container runtime, kubelet, and kube proxy. Those components are provided by the Kubernetes. It is a worker node components, we can say. So that is provided by the Kubernetes cluster. So what are the master nodes? For the master nodes, host master node host your control plane components that are managed that are used to manage the clusters. So what is a master node exactly? Master node have several components. It is work as a administrator to manage the worker nodes inside a pod. There could be a multiple worker nodes inside a pod. There could be multiple containers, or there could be multiple pods under the master node itself. So master node provides several we can say several components such as API server, scheduler, control manager, and cloud control manager, and etcd. So there are several components that are provided by the Kubernetes master node itself. We'll understand what are them exactly, what is the use of API server, scheduler, and the controller manager, and overall things. So let's look what is the architecture of the Kubernetes. Here is the architecture of the Kubernetes itself, and what is a master node which is present in the Kubernetes cluster itself. What the master component will do. So we look into that. So master component is responsible for managing the cluster. It will manages the entire cluster, as well as it will manage the node itself. So you can access the master container with the GUI, with the API, or with the kubectl command line tool, such as Docker has a Docker CLI, such as the Kubernetes also have a kubectl. So with that you can manage the worker node and the master and the worker node itself. So master node watches over the master node watches over the nodes, the cluster, responsible for the actual orchestration of worker nodes. So as I said, the master node will manages the worker node. Inside that worker node, there are separate components that are present inside the worker node, such as the kubelet, kubeproxy, the container runtime, and all those things. Inside the particular node, your application is present there. So with that, with this application, it will with each pod, the master, we can say the cluster will automatically assign a cluster IP to that particular machine, particular pod itself. This particular pod will only accessible to the master node and the inside the cluster only. There are no outside access to this particular cluster itself. So throughout that, it will achieve fault tolerance, and more than it will achieve the fault tolerance. And there, for the high availability, there could be 3 master node and a 3 worker node architecture will be there. Okay, so there are 4 components which are present inside a Kubernetes master cluster, which is etcd, the scheduler, the controller, and the API server. So what are they? So etcd is a distributed key value store. etcd used to provide basically it will store information in the key value pair. It will use to store all the data that used to manage by the cluster. So it have multiple nodes and multiple masters in your cluster. It is ready to store all the information on the nodes in the cluster in the distributed manner. So the data will be stored in the distributed manner inside the nodes itself. etcd is responsible for the implementing logs within the cluster, ensuring there is no conflicts between the masters. So it will provide provide a key value store to keep the information inside the nodes itself, and it will store in a distributed manner. So it is overall about it. What is the scheduler? The scheduler is a master component itself. Scheduler is responsible for distributing work across the multiple nodes. Inside a nodes, there could be multiple inside a look, it is a node. So uh, uh, the scheduler is responsible for distributing the work across the multiple nodes. The It will also assign the newly created container will automatically assign to the node by the scheduler also, scheduler itself. So what is an API server? API server used to communicate with the rest of the cluster with the kube API server with the main access points in the control plane. So the node and the master will communicate with the API server itself. It validates the user REST command. The kube API make sure that configuration of etcd match with the configuration of container deployed in the cluster. It will also manages it will also look it will also look the configuration that are match inside the etcdr that are present and active in the that configuration are deployed and basically the kube API server makes sure that configuration of etcd that are present in the key value store in that etcd matches the configuration of the container that are deployed in the cluster itself. So it will match those requirements inside the nodes itself that are matched with the etcd itself. So what is a controller manager? Now we look into the controller manager. Here it is. Controller manager is the brain of orchestration. It is responsible for noticing when container endpoints are going down. So if some of the containers are going down, it will automatically make decisions in such cases. The kube controller manager runs on a continuous loop. It will kind of ping with that particular node continuously if to manage the state of the cluster by checking if required deployment replicas and nodes are running in the cluster. So replicas are set. Replicas are basically if your organization are getting multiple traffic, so you can set the replicas. My desired requirement is a 1. My application desired requirement is 1. If there is no load on the application, it will run on one container itself. And like if there are if there are multiple people are coming to the requests are coming, there could be auto scale to the thousands and thousands of containers. So you can basically the replica is for that. You are creating a replica. You are replicating your application in the distributed manner inside the node architecture itself. So there could be thousands of nodes inside a multiple master nodes that will manage the nodes. Basically, we can call them as a replicas. So it will check the state by the deployment by the nodes itself. If some nodes are going down, then it will try to match the deployment requirements. So what is a kubectl? As I said, when we are working with the Docker itself, we are using the Docker CLI commands, and now we are looking into Kubernetes. There is a utility to manage the Kubernetes command, which is a kubectl, which will interact the Kubernetes cluster. Why it is called as a KATS? It is quite easy to understand. The Kubernetes letters have Kubernetes have 8 letters, so they call them as a or KATS. So it is provide a API server to interact with the Kubernetes server. It is with the kubectl command. You can directly query, or you can directly do activities on the master inside the cluster itself, you can say. So it also provide a command like tool or kubectl known as a kube control. So it uses to deploy and manage the applications that are running on the Kubernetes. So there is a command which is kubectl nginx run, and cluster info and the Kubernetes get nodes. It will provide all the nodes. It will provide the list of all the nodes. It will provide the information about the cluster, and it will provide the deployments that are done in the application. The deployments are done in the deployments.yaml. I'm writing this on the mouse itself. Deployments.yaml. The cluster will create when this architecture is working. So the master and the worker node architecture is known as a cluster itself, and you can store under the you can store the master node and the worker node inside a namespace. We can call it as a namespace. So Kubernetes get nodes. So individual nodes are present there. You can get the nodes information with this command, Kubernetes get nodes. So as we seen the master node, overall the things about the master. Now let's look what is the worker node architecture and how the worker node, what are the benefits by using the worker node itself. So worker node present of a kubelet, kubeproxy, and the container runtime. It is called as a Docker also, and it is present inside the Kubernetes worker node itself. The worker nodes have a kubelet that are responsible for interacting with master, provide a health information of the worker node itself. Kubelet which is responsible, such as the controller is working right. So it will look for the if something bad happens, if some container endpoints are going down, that automatically note by him, and it will do the activities automatically in such cases that are already defined. So it is quite same. It will provide a health information of worker node to the master node. So it will carry actions that are requested by the master and the worker nodes. To carry action requested by master node on the worker node itself. It will provide a utility to basically interact with the command line tool and all those things. What is a kubeproxy? Kubeproxy is responsible for ensuring the network traffic, the routed properties of the internal and external world. What are services that are required by this node itself? What are the rules and the network policies, and kube control manager will define we can define the custom network policies. We can provide a load balancer. Kubernetes also support the load balancer. With this we can expose the particular code inside the worker node itself. There is also one networking type which is ingress. There are some rules we can provide, such as the ingress rule, or we can expose the node code, and we can look the overall things inside the in the later part of this video and all those things. So what is a Kubernetes architecture? This is K3s. K3s is another thing which if you need to replicate the Kubernetes environment on your local, you can use the K3s. You can do the practicals on the local machine itself. So it is provided by the Rancher Labs and basically by the SUSE, and it will work. So we'll look what is it exactly. So what is pods? As I said, pod is basically a container which is wrapped inside a box, which is called as a pod. So pod is a scheduling unit for the Kubernetes. Pod is a ephemeral in nature because pod doesn't have any storage and all those things. It is ephemeral in nature. Pod is often ephemeral, so Kubernetes doesn't run containers directly. Instead, wraps over the one or more container into a high level structure called as a pod. As I said, it is the smallest deployment unit that you can create it, scheduled and managed on the Kubernetes cluster. it will assign a unique IP address by the provided by the cluster itself. Pod can hold multiple containers as well. You should limit when possible. You should limit when you are possible, because the you can say um, each each pod can contain one container itself, but there could be, you can for the best practices for each pod you can place one container itself. So there are another options such as sidecars. There are another technologies such as sidecar and all those things that we look later part of this video. If some container requires to read a file from the another container, such as logs accessibility. So and at that case we can do this activity, but not now. We can use the sidecar containers and all those things later on. So all the containers must scale together regardless their individual needs and lead to the waste of resource. So this is the pod, and any container with the same pod share the same storage volumes and share storage volumes and network resources. Communicate with using localhost. If the two containers are present inside the pod itself, they can communicate with each other by the localhost, and it will able to share the same host. As I said, if some container needs to read some file from another container, so you can do that. With the KTS is totally working on the YAML itself, or YAML formatting itself. So because of that, I would recommend to learn YAML to desired state. Uh, Basically, with the with with the YAML file itself, you can specify the desired state and the content. You can provide a pod specification inside that YAML file. Those objects are passed to the kubelet through the API server. So pods are a unit of replication in the Kubernetes. If your application becomes too popular, the single pod instance can carry that much load. So Kubernetes will create a multiple replicas of that, and it is done by the pod specification. According to spot specification, it will automatically scale up and scale down. So what is the scaling pods? A container can scale within it can scale together. You cannot scale individual containers within the pods. The pod is a smallest unit. The pod is the unit in the Kubernetes itself. In the recommended way, you can place one container inside a pod. You can have multiple containers. It's very rare. You can place multiple pods in the. You can place multiple container inside a pod, and this is about the scaling itself. So what is a you don't need to learn what is an imperatively, declaratively, and all those things. What are the manifest file? Those are manifest files that you can provide the total manifest of your application, that we're looking into when we are doing the project itself. So this is the things you need to learn right now, and we'll look the overall things in the later on itself. So that's it for today.